Ever wondered what secrets Pluto hides on its icy surface? Today, I'm revealing astonishing images that you absolutely need to see. From breathtaking landscapes to enigmatic formations, you'll be amazed by what we've uncovered. Let's explore Pluto together. This breathtaking global view of Pluto was created by combining 4 images taken by NASA's New Horizons Long-Range Reconnaissance Imager, LORRI, with color data from the RALPH instrument. This composite image provides an incredible view of Pluto's surface, revealing intricate details and features. The images were captured when the spacecraft was 280,000 miles, or 450,000 kilometers, away from Pluto, showing features as small as 1.4 miles, or 2.2 kilometers. This is twice the resolution of the single-image view taken on July 13th. Although the lower right edge of Pluto in this view currently lacks high-resolution color coverage, the image still highlights the diverse and complex terrain of the dwarf planet. The bright, heart-shaped region, known as Tombaugh Regio, stands out prominently, showcasing the dynamic surface processes at play. Tombaugh Regio, with its distinctive heart-shaped appearance, is a fascinating feature of Pluto's surface. The left lobe, called Sputnik Planitia, is a vast, icy plain covered with nitrogen ice, while the right lobe is characterized by rugged, mountainous terrain. This contrast highlights the varied geological activity on Pluto. This image offers valuable insights into the planet's geological history and composition. By studying these detailed images, scientists can learn more about the processes that have shaped Pluto's surface, including the presence of ice and other volatile compounds. New Horizons has allowed scientists to examine Pluto's surface in unprecedented detail, revealing features such as mountains, valleys, and potential cryovolcanoes. These images provide clues about the internal structure and thermal evolution of the dwarf planet. Pluto's complex and diverse surface makes it an intriguing target for future exploration. Understanding its formation and geological activity could shed light on the broader processes at work in the outer regions of our solar system. This stunning composite image of Pluto features Sputnik Planum, the smooth, light bulb-shaped region on the left. This area is characterized by its relatively smooth and bright surface. Sputnik Planum, informally named, is a fascinating feature of Pluto's surface. This smooth, icy plain is part of the heart-shaped Tombaugh Regio and is primarily composed of nitrogen ice. The smoothness of Sputnik Planum suggests a young surface, constantly renewed by geological processes. To the right of Sputnik Planum is a brilliantly white upland region. This area may be coated by nitrogen ice, transported through Pluto's thin atmosphere from the surface of Sputnik Planum and deposited on these uplands. This process highlights the dynamic interactions between different regions on Pluto. The nitrogen ice found in this area and the surrounding uplands is a key component of Pluto's surface. These icy deposits are transported through atmospheric processes, demonstrating the planet's active and ever-changing environment. The presence of these volatile compounds provides valuable insights into Pluto's geological and atmospheric history. Just 15 minutes after its closest approach to Pluto on July 14, 2015, NASA's New Horizons spacecraft looked back toward the Sun and captured this stunning near-sunset view. The image reveals rugged, icy mountains and flat ice plains extending to Pluto's horizon. The smooth expanse of the icy plain known as Sputnik Planum stands out on the right. This region is characterized by its relatively smooth and bright surface, which contrasts sharply with the surrounding terrain. Flanking Sputnik Planum to the west are rugged mountains up to 11,000 feet, or 3,500 meters, high, including the informally named Norgay Montes in the foreground and Hillary Montes on the skyline. These towering peaks add to the dramatic landscape of Pluto's surface. To the right, or east of Sputnik Planum, lies rougher terrain cut by apparent glaciers. These features hint at the complex geological processes that have shaped Pluto's surface over time. The backlighting in this image highlights more than a dozen layers of haze in Pluto's tenuous but distended atmosphere. These haze layers extend high above the surface, providing valuable insights into the composition and dynamics of Pluto's atmosphere. Pluto's haze layer shows its striking blue color in this picture taken by the New Horizons RALPH multispectral visible imaging camera. This high-altitude haze is thought to be similar in nature to that seen at Saturn's moon, Titan. The source of both hazes likely involves sunlight-initiated chemical reactions of nitrogen and methane, leading to relatively small, soot-like particles known as tholins. These particles grow as they settle toward the surface, creating the beautiful blue haze we see in this image. This image was generated by software that combines information from blue, red, and near-infrared images to replicate the color a human eye would perceive as closely as possible. The result is a stunning representation of Pluto's atmosphere and its unique characteristics. The similarity between Pluto's haze and Titan's haze suggests that these distant worlds may share common atmospheric processes. The informally named feature Wright Mons, located south of Sputnik Planum on Pluto, is a truly unusual landmark. This massive feature spans about 100 miles or 160 kilometers wide and rises to an impressive height of 13,000 feet or 4 kilometers. At the center of Wright Mons, you can see a summit depression that's approximately 35 miles or 56 kilometers across. The depression's rim displays concentric fracturing, adding to the intriguing nature of this feature. The sides of Wright Mons exhibit a distinctive hummocky texture, suggesting complex geological processes at work. This texture, along with the concentric fracturing, provides valuable clues about the mountain's formation. New Horizons scientists believe that Wright Mons and another nearby feature, Pickard Mons, could have been formed by cryovolcanic eruptions of ices from beneath Pluto's surface. These cryovolcanoes would erupt with a mixture of water, nitrogen, ammonia, or methane, contributing to Pluto's diverse and dynamic geology. In this extended color image of Pluto, we see the rounded and bizarrely textured mountains, informally named the Tartarus Dorsa. These mountains rise up along Pluto's day-night terminator, showcasing intricate but puzzling patterns of blue-gray ridges and reddish material in between. This view, roughly 330 miles, or 530 kilometers across, reveals the complex landscape of Tartarus Dorsa. The image combines blue, red, and infrared images taken by the Ralph Multispectral Visual Imaging Camera on July 14, 2015, and resolves details and colors on scales as small as 0.8 miles or 1.3 kilometers. The intricate patterns of blue-gray ridges and reddish material in Tartarus Dorsa highlight the dynamic geological processes on Pluto. These colors and textures provide clues about the composition and history of the surface materials, including the presence of various ices and tholins, which are complex organic compounds. By combining blue, red, and infrared images, scientists can create a more comprehensive view of Pluto's surface. This technique enhances our understanding of the planet's geology and composition, allowing us to see features that would be invisible in a single wavelength. Studying Tartarus Dorsa helps scientists unravel the geological history and evolution of Pluto. The mountain's unique textures and colors provide insights into the processes that have shaped the planet's surface, including the role of tectonics, erosion, and atmospheric interactions. That's all for this one. Thanks for watching. And if you liked this video, you know the rest.